Okay, sorry again. Good morning, dear guests, our colleagues. Welcome. I'm really sorry. We have a really technical problem that I can't hear my voice at the same time. Can I start again? Okay. Sorry, our guests and colleagues, welcome. It's our pleasure and honor to welcome all of you again. It's to the 3rd International Şişli Science Congress, second day opening ceremony. Today, I would like to tell you more about our scientific congress. As a matter of scientific knowledge and sharing, we held the International Şişli Science Congress in 2019 and 2021 with the participation of scientists from many countries in order to create a new platform for the scientific world and academic studies. In this era, of information, rapid digitization process prevails over all area of social life. The global impact of pandemic has also accelerated the digitization process. Today, science, technology, digitization, and innovation are topmost priorities on our agenda. In line with these developments, we are organizing the 3rd International Şişli Science Congress. We want to extend a special thanks to the members of the 3rd International Şişli Science Congress Committee. It was a great honor to work with you. We believe that the annual International Şişli Science Congress brings students, researchers, scientists, colleagues, and technologists together. We hope it will gain new connections and find colleagues for future collaboration. With us today, the esteemed Professor Dr. Theodor Iliev from the University of Rus Angel Kenchkev, Bulgaria. In conjunction with the event today, Professor Dr. Iliev will be delivering his opening speech. We are proud and honored to have Professor Iliev join us today, and I would like to thank him for his time. We would also like to thank Angel Kenchkev University for their participation in our collaboration that we have done together. I would like to present for his second day opening speech. The floor is yours, Mr. Iliev.
Thank you, Ms. Babagu. First, did you hear me?
Theodor Iliev, Mr. Theodor Iliev, we can't hear you.
Or not?
Ondan kaynaklı bir şey değil mi? Mr. Iliev, we can't hear you. We can't hear your voice.
Do you hear me? Если включу мать этого сушить.
Şu an sadece
Sanem, did you hear me now or not?
Yes, we can hear you now, Mr. Iliev.
Yes or not?
Yes, we can hear you now.
Okay. Some technical problem.
Okay, no problem.
From my side, from your, that will be the last technical problem. Can I share my presentation?
Please share your presentation.
Did you see my slides?
Yes, we can see.
Okay.
Mr.
Today I want to share with you one presentation with the title Network Towards to the Future 6th Generation Mobile Network. We all know that every decade is established a new generation of mobile communication. I show on this slide. In the late 1980, we start with the first generation mobile network, and approximately at 2020 was started the 5th generation network. And between them, every decade is new generation, like 2nd generation, 3rd, 4th generation, LTE or LTE Advanced, and etc. LTE or LTE Advanced standards performance need to keep up the high data throughput, great cell capacity, and more reliability. Thus, the new standards are being developed to performance goals and technology. And on the other hand, there is a very limited available below 6 gigahertz. So millimeter wave can encourage wide bandwidth transmission are being investigated for the next generation system. And in order to define new channel models as millimeter, research and development needs to understand how the radio signal will propagate at the given frequency. This frequency loss. Next generation mobile network find the main 5G network requirements, and they are as follows. Data rates of several 10 of megabit per second can be supported for 10 or 1,000 to be offered simultaneously to 10 of workers on the same office floor. Up to several 100,000 simultaneously connection to be supported for massive sensor deployments. Spectral efficiency should be significantly enhanced compared to 4th generation network. And it's possible device-to-device and car-to-car or vehicle-to-vehicle communication. What is changing when we compare the previous mobile standard and the new 5th generation network? With 80%, the mobile data traffic grow. 80% of mobile data traffic will be given by video. 85% of all subscription will be for mobile broadcast. And also more people will watch stream on the than linear TV production. The main advantages of 5th generation network are as follows. Interruptibility become possible. Low battery consumption of smartphones. All of us know that it's for us a big problem when the battery is low and we need to establish connection or to search something in internet. Other is better coverage and high speed data transfer. Multiple ways for data transfer simultaneously. Greater spectral efficiency and better quality of services. A lot of uses cases for 5th generation network, but I show some of them. The 5th generation will be the main network in smart transportation and also in smart homes, smart cities, smart grid, in robotics, in automation, like industrial in automation industry 4.0, in unmanned aerial vehicles, or interaction with things. What is the main requirement to the 5th generation network? And the first is the power efficiency, multiple year battery life, and network cost. That means all devices to be cheaper. Long range and deep coverage, high reliability, ultra low latency, down to second end-to-end latency between two users, high availability, multiple tolerance, and mobility. Here we can see the main characteristics of 5G network. Figure number 1 is shown the 5G network, and this network uses the flat IP concept access network with the same nano-core technology for communication. And the main functionality characteristic of 5G networks can be summarized to enhance mobile broadband, latency reliable communication, massive Internet of Things, or massive communication. On this table are presented the operational of the 5G network, and the main is that the cell edge data rate is approximately 100 megabit per second, and later less than 1 millisecond. And also the frequency range is between gigahertz. As shown in figure number 1, network concept for various radio access network. On this slide describes the 5G protocol stack as corresponding OC wire. And we see that OC wire are 7 wires. In 5G network stack, we have only 4. Some of them combine other from OC stack. Generation mobile communication network not only have to cope with but also provide a wide range of applications like device communication, vehicle-to-vehicle communication, massive machine type communication, moving network, and ultra reliable communication. Device communication in mobile network. In device-to-device communication, user with short distance and high signal-to interference plus noise ratio may directly communicate with each other without sending the information through the base station. This is the main idea. Device-to-device communication met the growing requirements of 5th generation. Must be ensured spectral and energy efficiency requirements. Main technology component in device-to-device communication is the mode selection. That means that we should select the communication mode for a device-to-device pair based on source condition, traffic load, and level of the interference signals. In the smart mobility management for device-to-device communication, that the device-to-device resource usage and coordination are under the network. Furthermore, the additional control overhead is expected due to change of information between the controlling node as depicted on this figure. Therefore, we propose a mobility management solution that can be used to minimize the negative impact, reduce the network signaling overhead caused by inter-base station information exchange. With the trigger handover solution, we propose to cluster the members of the network and a minimum number of cells or base station in order to reduce the network signaling. What is the generation? That is the traffic volume expansion of the mobile broadband. Second, massive growth in connected devices. We all know that every year, every moment, we use more and more connected devices at our home with laptops, smartphones, TV, or air condition, washing machine, and etc. And cases and requirements for device-to-device communication, car-to-car communication, and etc. The main technology components of a fifth generation network on the first place is the new spectrum band and access methods. Dense and moving network, multi-hop wireless backhaul, content-aware interference and mobility management, and air interfaces for new application and reduced signaling. Technology areas of 5G is extension of higher frequency, spectrum flexibility, multiple antenna technology like beamforming, MIMO systems, and etc. Coordination, access and backhaul integration, device-to-device communication I mentioned in my previous slides, and ultra. Now we will discuss something about vehicle-to-X connectivity. Now we have vehicles with electric vehicles, and the key element of the new intelligent transport systems, that is vehicle-to-X connectivity. Pedestrian, vehicle to sensors, vehicle to internet, vehicle to road, vehicle to vehicle. There is 3 different vehicles, like connected vehicles only. In this is communication, they have communication capabilities. Automated vehicles, some safety critical control function without direct driver input. And on the last is vehicles, self-driving capabilities without connectivity. Vehicle-to-X technology is giving to the vehicles the ability to communicate with each other and beyond, like with infrastructure, with another vehicles, with pedestrian, or with the network for real-time traffic. Vehicle-to-X communication technology is a main component in intelligent transport systems. And these requirements less than 100 millisecond latency and 1 kilometer. The frequency band is between 5.855 to 5.925 gigahertz. The main trends in automotive sector is to achieve the higher automation level, connectivity, and vehicular communication to share sensing data and enhance capabilities. If we summarize automotive sensor, they are three sensor we can divide like radar, camera, and LiDAR. On this table, we can show, we can see the purpose, the drawback, and the data possible to exchange roles all the vehicles on the road. Why is this? Because each of the sensor in the new cars or new vehicles, the new cars have a lot of sensors inside. And when we sum the data of each sensor or multiply the data of each sensor to the number of sensors in the vehicle, we at the end, we receive a massive amount of data per vehicle. And like an example, connected vehicle is expected to drive 1.5 gigabytes mobile data. Autonomous vehicles can generate up to 1 terabyte per driving. And for fifth generation network cannot support these data rates. That's why we should use the new technology as a fifth generation network. On this depicts of fifth generation millimeter wave with frame construction, and the main advantages of millimeter waves which are used in 5G network is that with millimeter wave they can be channels. Size of the antennas is physically small. So that means that we can reduce the supports multi-gigabit transfer rate suitable for mobile communication in 6 gigahertz range. On this slide is shown an example with use of millimeter waves for connected cars. And also with beam forming, we see that on right upper figure on the slide, that millimeter waves are around 20 gigahertz. There's a lot of challenges for millimeter wave. On the first, lack of propagation channel models, high penetration rate needed for most gains, and on another hand is more infrastructure. We need more infrastructure to be developed. With use of millimeter wave in the automotive industry or in a vehicle communication, we can increase sensing capability in the car. Joint automotive radar and communication is possible. New kinds of infrastructure to be deployed near the roads, and sensing technology can be used to help establish communication. Some challenges for millimeter wave technology: using position information to reduce beam alignment overhead in millimeter wave vehicle And another is each vehicle can decide from other vehicles' position and size info, as this is shown on this slide. Another challenges for millimeter wave communication is to adding radar to the infrastructure. The radar can capture information of the scattering environment used to design multi-user beam port remote car traffic control. Another is predicting blockage from out-of-band sensing. That means radar can detect potential obstacles and their associated mobility. Machine can classify particular radar response as blockages. On this slide, we can see the list of components which are needed for vehicle-to-vehicle environment. We started with GNSS Global Navigation Satellite System Receiver, device vehicle interface, memory, dedicated short-range communication, etc. Which are the main components of vehicle-to-vehicle environment? On the first place, that is onboard units, represent the DSRC devices, which are installed by the manufacturer. And these devices integrate directly with the vehicle's computers, which can provide additional information. And vehicle awareness devices only broadcast basic safety information. There's a lot of application for vehicle-to-vehicle communication. On the first is emergency vehicle alerts. That vehicles responding to an incident, vehicle emergency response, transit vehicle at station or stop warning, vehicle turning right in front of transit vehicle. Also, we have advanced automatic crash notification relay, cooperative adaptive cruise control, which advise driver recommended cruise speed based on information from other connected vehicles with a platoon. And queue warning, advise drivers of impending queues on the road. Another is connected eco driving, advises driver to adjust driving behavior to save fuel and reduce emission. And eco cooperative adaptive cruise control. All of these applications are shown on this slide. You can see one of them is forward collision warning, on don't pass warning, curve speed warning, and etc. Overcoming the challenges for vehicle-to-X communication and car-to-vehicle-to-X, like high relative speed, enhanced signal design, high node densities, enhanced transmission structure, more efficient communication, time synchronization, and a low utilization GPS timing. Enhanced to use satellite like a global navigation satellite system when it's out of coverage with the network. And what we can expect from the next generation network, which is under research and will be maybe this decade. The main requirements and key trends is that the future 6G networks are expected to increase the level of network with the donation of improved services from the perspective mobile data rate, and seamless connectivity. Generation communication systems are expected by the following associated services like universal mobile ultra broadband, mobile latency communication, ultra high speed with low latency, massive machine type communication, and etc. On this table, you can see the capability fifth generation network, and we can see that like an example, end-to-end latency in fifth generation networks is approximately 1 millisecond. Done in a sixth generation network is expected to be less than 1 millisecond. Another interesting is that mobility in fifth generation networks kilometer per hour, and the mobility is expected to be more than 1,000 kilometers. Here you can see the 6G architecture scenarios with different applications. We can start from Internet of Things, and artificial intelligence, machine learning, and etc. Technologies and concept and service, artificial intelligence and machine learning technology, which can be implemented in the 6G communication network in different layers, data links and network infrastructure, software-defined network function virtualization, and cloud edge fog. Of 6G networks, which helps the calculation to be performed as close to the Internet of Things devices as possible. Blockchain would consider the security of authentication and consequently the network and enhance the network performance. Also, terahertz technology waves, which open 0.1 terahertz till 10 terahertz. Which will be used in a sixth generation network is visible light communication. In comparison with radio frequency communication, has high latency and interference, but the visible light communication has magnetic interference. Also, 3D networks, healthcare will be significantly changed with 24/7 monitoring of the human vitals and autonomous system, intelligent transport system. And we can say that there is a tradition of inventing a new mobile generation standard approximately every decade. For this reason, the appearance of the 6G network at the end of 2030 is quite possible. Future research in the field of sixth generation wireless network will be further upgrade and complement the recent technology used in the 5G networks. In this regard, we will be introduced the use of terahertz technology in addition to millimeter wave, visible light communication, edge computing, and others. In 6G network will be achieved through development of artificial intelligence, machine learning technology. Thank you for your attention, and here you can see the references which I use to prepare my presentation. Thank you once again.
Thank you, Professor Dr. Iliev, for your presentation. We really appreciate it. I would like to ask our audience if any questions or would like to contribute or discuss something. Okay, I think no any questions or contribute. This concludes in our event for today. Once again, for this session, once again, we would like to extend a special thanks to estimate Dr. Iliev as well as Engel Kenchkev University for collaborating with us to hold third Şişli International Science Congress. We would also like to thank the participants and audience for attending the event. Your participation has been thoroughly appreciated. We hope that you have enjoyed participating and have been able to benefit from the discussion we have had. Once again, thank you for all your time. Our next session will be at 11. We would like to see you at 11 again. Thank you once again. Thank you, Professor Dr. Iliev.
To be with you on this Congress.
Thanks so much. We really appreciate that.